Hello friends, welcome to this new video, and today we will going to discuss paging. So paging is a very important topic in computer architecture as well as in operating systems. So let's start our journey. Okay, so in our previous class we already saw that how the processor and memory is interconnected. So this is the basic diagram that how the processor is connected with the memory elements, that there is cache and RAM that are called primary memory. So cache is directly attached with the processor and RAM is attached with the cache, and the secondary memory, that means hard disk drive or flash drive, that is directly attached with the RAM. So this is the basic interconnection between processor and memory. Okay, so how processor interact with memory? Okay, actually here I want to say that what is the role of the processor. So actually there are different processes running inside the system, but when we need to execute some process, then where and how that process will execute. So here the role of processor comes. So actually processor executes different processes within it. Okay, and to execute a process there are several steps which are performed by the processor. But now the question is how a process is available to the processor. So actually when a process is needed to execute, then processor will call that process. Now there is a fact. The fact is that a process cannot store itself as a whole inside the memory. Here memory means RAM. But why is it so? Because RAM is actually divided into smaller parts, into smaller equal parts. That parts are called frames. Now, generally, a process has a size of 4 bytes, but these frames have a very less amount of storage capacity. Now, it is clear to us that a single frame cannot contain a single process, but it is necessary that a process is present inside RAM because RAM is directly related to cache and cache is directly attached to processor. So it is necessary. But here we see that it is impossible to contain a single process inside a single frame. So what will happen? So here the concept of paging comes. So let's see that actually what is paging and how this problem is resolved. Okay. Okay, so actually the resolving technique of this problem is paging. So actually a process is divided into some smaller parts known as page. Okay, and this page is the smallest length of contiguous block of physical memory. This is a very important point and we will discuss it later. I just give an example. I think it will make easier to understand that what is paging. Okay, so suppose assume that a process has a size of 4 bytes. So we already saw that a single frame cannot contain a single process. So what happens? Suppose assume this process is divided into two pages. Each page consists of 2 bytes. That is, every page size is 2 bytes. Okay, because the total size of the process is 4 bytes and the process is divided into two pages. That is, each and every page contains 2 bytes of the process. Okay, so here bytes are also called as word. So word is also a very important term. We will discuss it in the cache mapping. Okay, I just give a diagrammatic explanation. I think it will also make easy to understand that how a process is divided into pages. Okay, so according to our previous assumptions, P1 is the process, okay, that is denoted by the red block, and W0, W1, W2 and W3 are 4 bytes of the process P1. That is why the size of P1 process is 4 bytes. And so after dividing into the two pages, the process is divided into two pages, page 1 and page 2. Page 1 consists W0 and W1 byte, and page 2 consists W2 and W3 byte. Okay, so that is how a process is dividing into several pages. So now we have to know that how the processes are stored inside the secondary memory. So there are several processes that are kept inside the secondary memory storage. Actually, a bunch of processes are kept as a unit inside the secondary storage device. Okay, suppose we consider HDD as a secondary storage device, that is hard disk drive. So actually, if we say about structure of hard disk drive, then there are several tracks in hard disk drive. Okay, each track consists of many sectors. Okay, now this every sector stores different processes within it. Okay, so I just give a diagram. From that, I think it is clear to you that how, that what is sector, what is track, and how this process is stored inside the sector. Okay, so we just consider hard disk drive as a secondary storage device. So here is the diagram. Okay, so these are the different parts of a hard disk, and so there we see that there are several tracks inside the hard disk, and there are sectors that are the smaller parts within the tracks, and within this every sector there are different types of data that are stored within the sector. Okay, how a process comes inside RAM through paging. So I already told that when a process is needed to execute, then processor will call that process. But actually that does not happens. Actually, when a process is needed to execute, then the words inside that process that are called by the processor. Actually, processor needs the words inside that process. Okay, so how these words are available to the processor? When processor need a word, then processor generates logical address or virtual address, and this logical or virtual address is transferred to physical address by memory management unit. This physical address tells us that this word is present in the which location of the main memory. So then processor will search the word in the main memory through this physical address. But suppose that word is not present in the main memory. Then what happens? Then processor fails to find that word inside the main memory. Then operating system takes the control in its hand. So then operating system will continue the search inside the secondary storage, that inside which process inside the secondary storage that word is present. Okay, so when finally operating system will successfully find the process inside the secondary storage where the required word is present, then that process is divided into some pages, and then that pages are transferred into the RAM. So that is how a process comes inside RAM through paging. So from here it is clear to us that paging is nothing but the technique by which the process is divided into some pages, and that pages will comes inside RAM. I created an animation which will help you guys to visualize that how paging works inside a system. Okay, so let's start our animation. That is the diagrammatic explanation of paging. So we already know that this is the basic interconnection between memory elements and processor. So suppose assume that there are P1, P2, P3, that there are n number of processes inside a sector, okay, inside the hard disk drive, that is a HDD. And suppose there are F1, F2, F3, F4, like there are 32 frames inside the RAM. Okay, there is an important thing that page size equals to frame size. When a page enters in a frame of the RAM, then that page must have to be fitted inside the frame. If the frame size is smaller than the page size, then that page cannot fit inside the frame. So that is why frame size must be equals to the page size. Okay, now we can proceed. So suppose the processor needs the word W1. Okay, so processor generates a logical address corresponds to W1, and then with the correspond physical address, processor finds that word inside the main memory. But suppose that word is not present inside the main memory, then what happens? Then operating system search that word inside the secondary storage device. That is, here we assume that our secondary storage device is hard disk drive. Okay, so OS continues the search. Now suppose operating system finds that word inside the process P1. So here we take our previous example that process P1 has a size of 4 bytes and the page size is 2 bytes. So what happens when operating system finds that this P1 process contains the word W1, so then this process is divided into two pages which consists 2 bytes each and every. Okay, so suppose page 1 consists W0 and W1 and page 2 consists W2 and W3. That is how the process is divided into pages. Now these pages are comes inside the RAM. inside the frames. Now this word is available in the main memory. Then this word is just transferred to the cache, and then from the cache that word is available to the processor. So that is how the paging works inside a system, and processor will get the required word. So I think that this animation will help you to visualize the concept of paging, and I think after seeing this animation the paging is clear to you. Okay, so now there is a big fact that if all the frames are full with different pages, all the frames of RAM is full with different pages, that means we can say that in this situation RAM is full. Now if I need to place some another new page into RAM, then what happens? How it can be possible? Because the RAM is already full with the different pages. Okay, so let's see that how it is possible. So the solution in this situation is known as page replacement. Okay, so what is page replacement? So we have to place some pages into secondary storage, and the required process will divide into pages, and that new pages will take place inside that empty frames. This is known as page replacement. Okay, so I think it is clear to you that when the RAM is getting full, then that old pages are transferred into the secondary storage device, and the required pages are comes inside that empty frames. Okay, so that is known as page replacement. Okay, so this paging and page replacement is controlled by operating system. Okay, in this page replacement there are two important terms. Okay, so the first term is placing of a page from the secondary storage to an empty frame is known as roll in or swap in. That is when a new page comes from the secondary memory to an empty frame of the RAM, then that is known as roll in or swap in. Okay, so the second term is placing of a page from a frame to the secondary memory is known as roll out or swap out. That is when the RAM is getting full, then uh, then an old page is getting transferred to the secondary memory, and that is known as roll out or swap out. So now there is another fact, that is when page replacement occurs, then how operating system knows that which page it has to roll out from the RAM. So according to which priority or which order we can roll out a page from the RAM. So there are different algorithms that are also known as page replacement algorithms. They decide that in a particular condition, in a particular situation, which page OS have to roll out from the RAM. So I just here give the names of different page replacement algorithms. So one is FIFO or FCFS page replacement algorithm. Here FIFO means first in first out, and also FCFS means first come first serve. Okay, so number 2 is LRU page replacement algorithm, that is least recently used page replacement algorithm. Number 3 is LFU page replacement algorithm, that is least frequently used page replacement algorithm. Number 4 is optimal page replacement algorithm. Number 5 is MFU page replacement algorithm, that is most frequently used page replacement algorithm. Number 6 is clock page replacement algorithm, and so on and so forth. There are several page replacement algorithms, and I just mention here the names of some famous page replacement algorithms. Okay, so that's all for the day. So here we end our session about the topic paging. So I think it is clear to you. And though if you have any doubts, then please comment in the comment box. So in the next classes, we will discuss different types of page replacement algorithms. So see you in the next class. I think you guys understand it and enjoy this slide. So don't forget to like this video and subscribe my channel, and also share this video with your friends. So see you in the next class. Stay home and stay safe.